Click the bell icon to get latest videos from Ekeeda.
Hello friends, so today we are going to do another numerical based on the topic of fiber optics, but this time we are going to focus something on the signal propagation, that is the V factor. So suppose you are given mu1, that is the refractive index of the core, and suppose you are given mu2, that is the refractive index of the cladding. You can actually find out the numerical aperture, and from this numerical aperture you can actually find out the V factor. So let us do a problem based on such a kind of data. Compute the maximum radius allowed for a fiber having mu1, which is the refractive index of the core, is equal to 1.47 and mu2 is equal to 1.46, wherein mu2 is the refractive index of the cladding. The fiber is to support only one mode at lambda is equal to 1300 nanometer. So what is the data that we have over here? The data that has been provided to us is mu1, which is the refractive index of the core, is equal to 1.47, mu2, which is the refractive index of the cladding, is equal to 1.46, and the fiber is to support only one mode. Now when the fiber is going to support only one mode, the V factor should be less than 2.405. So this is something which has come from theoretical derivations, something which we have to accept. Now after this, V is less than 2.405, and the last parameter which we have is lambda is equal to 1300 nanometer, which amounts to 1300 multiplied by 10 raised to minus 9 meters. So remember students, whenever we are doing any problem, the data is always to be converted into SI units. So that's the reason why we converted 1300 nanometer into meters. Now what is the formula for the V factor? The formula for the V factor is V is equal to, so let us write down the formula. Right? The formula V is equal to 2 pi into A divided by lambda into the numerical aperture, wherein what is A? A is nothing but the radius of the particular optical fiber that we are considering, and lambda is the signal that we are considering. NA, as you know, is nothing but the numerical aperture, which can be still written in the simplified form as 2 pi upon lambda into square root of mu1 square minus of mu2 square. Take a look at the problem and let us try to find out what is the problem asking you to do. It is actually asking you to find out the value of A for this particular step index fiber, that is the value of the radius. So I have to convert this particular formula for V into a formula that will exclusively give me A, and this is what I do next. So your A is equal to V into lambda divided by 2 pi into square root of mu1 square minus of mu2 square. So this is what we are going to do out over here. But there is one important suggestion which the problem has already given us, wherein the data suggests that we require only a single mode, and therefore for this we can always assume that the value of V is 2.405. Okay, so let us substitute this particular value of V as 2.405 and go ahead with the calculations. So this is equal to 2.405 because I want only a single mode, multiplied by 1300. It is in nanometers, so I'll have to multiply this by 10 raised to minus 9 divided by 2 into 3.14, which is the value of pi, and once again multiplied by mu1 square, which is 1.47 square, minus mu2, which is 1.46 square, and from here you can get the value for the radius of the required step index optical fiber as, and this value works out to be 2.906 into 10 raised to minus 6 meters, which is actually 2.906 micrometer. Hence, the required value of the radius for the optical fiber is A is equal to 2.906 micrometer. A is equal to 2.906 microns, and this is the required value of the optical fiber. Sincere thanks, students, for watching this particular video. Stay tuned to our channel Ekeeda and do subscribe to our channel Ekeeda. Thanks a lot.